G'day guys, how's it going? So in this video, we're going to look at the Boolean data type, and we're also going to look at the character or char data type. So both of these are pretty simple, so I'm going to put them in the same video, might as well. And basically, this will sum off all the primitive types that are in Rust, okay, or what we call scalar types. Anyway, let's get started. So I'm going to quickly start with Boolean because it's really simple. So to declare a Boolean, it's pretty straightforward. If you've done it in other languages, I can just go let a bool equal, and I can specify either true or false. I'll just go false in this situation. And you can see it's already picked up that we're using the bool data type. Cool. Can also do the same for explicitly setting it. So I could say another bool, and I can say I'm going to set it explicitly to bool, and then set it to true, like so. And then basically what I can also do is work out what the size of a boolean is. So I'm going to go let bool size, and we're going to make that equal to standard mem size of, and we're going to set the size of bool, right? So this will tell us how many bytes a boolean uses, right? Which I pretty much know the answer to this already, but let's just quickly print it out anyway. So I'm going to go print ln, and we'll say a bool, and set it to a bool, like so. And then I'm just going to copy this 2 more times, and we'll just quickly another bool, and then I'll just put a bool is bool size byte in size. That kind of gives it away, right? So if I now save that and I run this application, what we're going to see is when it looks for the parameter a bool in the print statement, it replaces it with false for the first one because we implicitly set it to false. And then the second one is we explicitly set it to true, as well as we specified the type. So you can see that's set to true down here. In fact, we explicitly set the value for both, I should say. But basically, you know, we explicitly set the type for the second one. And then we've got the size, which, like I said, is going to be 1 byte, right? So that is how we store a Boolean. And people might ask, well, it's really just a bit, right? Why is it just an individual bit? Well, that's because in programming, we deal with bytes. We don't deal necessarily with individual bits unless we're going to get very low level in our code base. And even then, we still process instructions byte size. So that's a Boolean, pretty straightforward. Now let's have a look at characters. So this is pretty simple as well. We just need to come in and define, say, a character, and we can specify to a singular character, that's on our keyboard, say like an A, right? But what we can also do is we can specify Unicode characters, right? So we can do something like this, where we go a Unicode char, specified as a char equals, and then we're going to grab quickly from Visual Studio a little fire symbol. So I'm just going to quickly go Control Shift P, insert Unicode, and I got a little fire symbol there, right? So I'm going to add that in, and there you go. The little fire symbol is added as a singular character. And this is valid for Rust, believe it or not. You can actually do this. And then lastly, we'll just get a character size, right? And this will be set to, similar to above, standard mem size of, and instead of bool will be char, right? And this will illustrate that a single character, which you would normally think should be stored in a singular byte, because that's usually how it works when you're using ASCII, you'll see something different here in a second. So I'm going to come down and I might just copy these 3 lines just to speed things up a bit. And then we'll just go a character, oops, spell it right. And then we'll change this one to a Unicode char. And that will be set to a Unicode char. And then we can say a char is, and I'll give you a hint, it's going to be multiple bytes, a character size, bytes in size. Cool. Now, if I rerun this, what we're going to see is we've got the same 3 Boolean results, but then we've got a character. You can see it's set to that individual A there. A Unicode character, it actually does print out at the terminal the actual symbol that's associated to that Unicode character. And then it also tells us that each character is actually 4 bytes in size, right? Because we're storing Unicode, and Unicode is not always necessarily a single byte of information. It can be more than that. It can be a little less than that, but generally they'll fit it inside of a 4-byte object, or what they call a word in C++, I believe. So yeah, just be mindful that in some other languages, a char is usually referred to as a singular byte of information, which is just a character like an A, B, C, D, whatever. It's basically inside single quotes. But in Rust, it actually represents a single Unicode character. And letters like A and B and C also fit into that Unicode set. Cool. So that's it for this video. So I will see you in the next one.